Hey guys, welcome to Circles topic, learning target 10-1A. I can determine the measure of an arc. Okay, so to be able to do this, we kind of have to talk about a couple things we've already talked about. A central angle, remember, is an angle with its vertex at the center of the circle, and its two sides are radii. The sum of all central angles is 360 degrees. So the whole circle is 360 degrees. Okay, so circle B equals 360 degrees. Okay, and so if you really want to think about this, that central angle there is 84. Okay, and so then you would find the whole distance around. Now, the degree of the arc, okay, formed by the endpoints of the central angle is equal to the degree of the central angle. So if you look at here, ABC is 84 degrees, then arc AC is also 84 degrees. Okay. And then ADC, which would be this way around the circle, would be 360 minus 84 degrees, which would be 276 degrees. So we can kind of use that to kind of help us here. So if we go down and take a look at our first example, we want to find arc AB. Well, A to B is the same as its central angle, so it'd be 95 degrees. And then if we want ACB, that would be the whole distance around, so we take 360 minus 95, which would be 265 degrees. So we're going to use that idea kind of to help us with the rest of these. Okay, so some of these are going to get a little tougher. Now, if you go to the second example, what I like to do is figure out the different parts before I go look at the other side, okay? But if they tell us right here that this angle is 21 degrees, that's the central angle, then that means this arc out here is 21 degrees. And if I work across the circle this way, we know these are also vertical angles. So this would be 21 degrees as well. And then how could I find the missing piece right here? Well, here's something really cool. This is a diameter, which makes this a semicircle. A semicircle is half, so that's 180. So we can take 180 minus 21 to get 159 degrees, like that. And then I can go answer my question. So if I go JK, that's 21 degrees. Okay. JNM. Now this says angle JNM. Angle JNM is right here, which is the same as this arc out here. So I now know this is 159 degrees. Okay. K to L, we can see is 159 degrees. JK to M, now this is a fun one. So if we go J to K is 21, K all the way to M. So basically we can just add all of those. But if you start to look, we got a semicircle plus an extra 21. So we got 180 plus 21 is 201 degrees. And then MKL, so we're going to go MKL. So that's the whole circle minus a little part. So I would take 360 minus that little part. We get 339 degrees. So that's how we kind of use our arc measures. So kind of just continue with that idea for our last few examples. Okay, so if this is 87, then this is 87 out here. Okay, and then they tell us that we can kind of find this piece right here is 72. So if this piece is 72, I can take that over. So that's 72. And then if you look here again, now we got our 180. Here's our 180, so we can find that little piece. Okay. So if we go 180 minus 87 minus 72, that's this little part right here. And then we can find the last part by taking 180 minus 72, will give us this part of 108, because this is a semicircle. Now you can kind of fill in your pieces. Angle U, X, Y is this part right here. So now we know this arc is 72. So we know this is 72 degrees. S to T we already found is 21 degrees. W to V is all the way around 72 plus 21 plus 87 plus 72. It's 252 degrees. Oh wait, I did that wrong. That would be a major arc. We have two letters, so it's a minor arc, so I messed that up. It's just this way, which we already found is 108. T to W, the short way, would be 72 plus 21, which is 93 degrees. And then TVW would be the long way around, because that's three letters. So TVW. So T to V to W. You can add all of those, or take 360 minus this part here. So if we take 360 minus 21 minus 72, it is 267 degrees. Okay. And then if you look at the last one, the last example here, this is a 90-degree angle, so that makes this 90 degrees. And if the D to E right next to it, notice that would make a semicircle, so this has to be 90 degrees. And then you know this would be, to find GF right here, we can just take 90 minus 34, because they kind of work together. So that's 56. And then this one would have to be 90 over here because of your 180. So see how we have those diameters in there. So then C to D is 90. F to D, so we start at F and go to D the short way, would be these two parts right here. So 90 plus 34 should be 124. And then the next one says DCF, so here's D to C all the way to F right here. So DCF, well, if you think about it, we just found what F to D is, so we can just subtract that from 360. So 360 minus 124 is 236 degrees. And GDF would be everything all the way around except for this little spot right here. So we take 360 minus 56, which should be 304. And that's how we find arc measures using central angles. So reminder, the central angle is equal to the arc measure of the same arc.